All right, folks. Last Thursday, we had finished up the part 2s, 3s, and 4s for the January 2014 Regents exam. We are just going to continue on with the part 1s. We had gotten through probably about the first third of the part 1s, I believe. We were looking through here. We saw that number 2, number 4, number 5, and number 8 were all straightforward calculator ones. We didn't need to know anything about Algebra 2 trig level mathematics. Just knowing our calculator, we were going to be able to get 4 of those first 8. Correct me if I'm wrong, but I do believe we looked at 9. Yes, and we had choice number 4, 11 letters, 2 repeated M's, 2 repeated A's, 2 repeated 2's. Did we start 10 yet? All right, that's where we'll pick up then. So we've got compounding interests, just a simple example of exponential functions. This one particular here being exponential growth. We're investing $5,000. 3% interest, compounded how? Quarterly. What does quarterly mean? 4 times per year. 4 times per year. What is the value of the investment after 5 years? So they have provided us with the formula. What does the P represent? That's our $5,000 principal. That's what we're investing. What does the R represent? The interest rate. How do we have to enter it, though? A decimal. Yeah, we've got to enter it as 0.03. What does the N represent? Number of times per year, which for us is 4. And then the T is the number of years. So we want to know the amount after 5 years. Well, that's going to be equal to our $5,000 interest, or I'm sorry, $5,000 principal. 100% of what we already have, plus 3% compounded quarterly for 5 years. Can we type that in all at once? We absolutely can. We just want to be very careful. We want to make sure that we're including parentheses where we should. We make sure we close off our parentheses. But we start off with 5,000 times 100% of what we already have, plus now we need another parenthesis for the fraction, the 0.03, the 3%, compounded quarterly. We'll close the fraction. We'll close the whole quantity. And then we're going to raise it to, now, it would just be a lot easier to raise it to the what? 20th. Now, if you're not going to raise it to the 20th, if you are going to do 4 times 5, what do you have to have? Another set of parentheses for the 4 times 5. Without that set of parentheses, it would just get raised to the 4th power, and then whatever you get there, it would be multiplied by 5, so no batteries. So, they want this to the nearest cento. We're looking at choice 2 in a row, huh? Choice number 3. Choice number 3 for us, $5,805.92. Okay, so after 5 years, we've gained a little over $800 on our investments. Number 11, what kind of an equation do we have? What do we always do to quadratics no matter what way we're going to solve them? Yep, so what are we going to get here in standard form? 2x squared minus 9x plus 4 equals 0. Now, folks, do they want to know what the actual roots are? No, they don't want to know what the roots are. They just want to know the nature of the roots. They want to know if they're real or imaginary, rational or irrational, equal or unequal. Can I completely solve this quadratic to determine that? I absolutely can. But is there a shorter way around it? What are we going to compute? Just the discriminant. Yep. And what is the discriminant? B squared minus 4AC. Okay? That's the most important part of the quadratic formula. It's the part that's found under the radical. So if this number ends up being positive or negative, that will tell me if I'm real or imaginary. If it's a perfect square or not, that's going to tell me if I'm rational or irrational. And then if it's equal to 0, I'll have equal roots. If it's not equal to 0, I won't have equal roots. So what is our B value? -9. That'll get squared. Then we'll subtract off the quantity of 4 times times 4. So we're looking at 81 minus 32. Over here we've got 81. 4 and 2 is 8, and 4 is 6. I'm sorry. Yeah, that's right. 4 and 2 is 8 times 4 is 32. So if we take 81 and subtract off 30, we have 51 minus 2 more gives us 49. Real or imaginary? Real, because it is positive. Yep. Rational or irrational? Because it's a perfect square. Equal or unequal? Unequal. Again, the only time they're equal is if it's 0. Yep. So we have real, rational, and unequal roots. Okay. Now again, folks, we could have solved this down. As we look at this one, what's 2 times 4? 8. Are there any factors of 8 that would add together to give me 9? I absolutely could have factored this. I would have factored this, and I would have found out my 2 answers, and I would have found out that they were real, they were rational values because they were their whole numbers or fractions, and we would clearly see that they weren't equal. But have we done a lot more work than is necessary? Could I graph this and find the roots graphically? I absolutely can. So let's review this concept. Let's type in the 2x squared minus 9x plus 4. And then I'm just going to go to a normal zoom 6. And here's my quadratic. And the roots to an equation are the what of a graph? The zeros. The roots are the zeros. Okay? So can my calculator find the zeros? Now, can we clearly see that they're not equal, though, when we graph it? We can clearly see that they're not equal when I graph it. And I can also clearly see that they are not imaginary. If my roots were imaginary, where would that quadratic be? Completely above it or completely below it? It wouldn't touch it at all. Okay, so I know they're not equal because there's 2 different spots right there, and I know they're not imaginary because it does cross. Well, let's just find out what one of them are. If one of them is rational, then the other one's got to be what? But if the one's irrational, the other one's got to be irrational. They have to come in pairs. So second trace, option what? Option 2. Where my spider is blinking right now, is that to the left of this first 0? Yes, it is. So I'm going to go ahead and hit enter. But now I need to move it to the right of that 0. Am I now to the right of it? Yes. I wish instead of asking left and right on the calculator, they'd ask like above and below. It seems to make more sense. But when it opens upward like this, left is over here, right's over here, and then it's going to switch on the other side. So that is our right bound. That's going to be our guess as well. 0.5, is that a rational or an irrational number? That's very rational. It's 1/2. Okay? So even graphically, is that going to be quicker than actually solving it out by hand? Absolutely it would be. So there's a lot of ways around this question if you don't remember the discriminant. But the discriminant makes it a real quick one, which is why it should be a multiple choice one. All right, let's count at 11. Okay, so can we kind of check mark or star 10 or 11 as knowing nothing, being able to get it right? I'm going to say 11 we can. Say 11 we can. Did what I just did on the calculator, is that Algebra 2 trig level mathematics? Nope. Nope. So I'm going to highlight number 11 as well. That's another one that we could do on the calculator. So we now have 5 of 12. I'm sorry, 5 of 11. Okay. Slightly less than half that we can do on calculator. Sliding down to 12. Haven't seen 12 in a while. We've gone over an inverse variation question in review before, but we haven't seen it since one of the first couple nights. Inverse variation, it typically was on every test at the beginning, but then they got away from it a little bit. It's kind of been on every other. It's definitely a question that I would expect to see, though. What's the key with inverse variation? And I like inverse variation because it's another concept that you not only saw this year in Algebra 2 trig, but you also saw it in chemistry. What's inverse variation mean? Yep, as one increases, the other decreases, but they will always have a constant what? Product. They always have a constant product. So you guys remember from Boyle's law, the formula, P1 V1 equals P2 V2. This means is that when we multiply the two variables, whatever value we get, whatever constant number we get, it's always got to be the same. Okay? Now, they can make a very easy inverse variation question like this one. They've also made them very difficult as well by giving you, a value like x when the other one is x plus 2. And 5, what is the other one? And now this turns not only into an inverse variation, but you're going to have to solve a what? You're going to have to solve a quadratic to figure it out as well. Okay? All right, if it's in part 2 where you're showing your work, but that was a multiple choice question. So if you understood the inverse variation concept, you could still get a complete 0 on that if you solved the quadratic incorrectly. Okay, it's a terrible question to have there. This one's good, though. What are my two variables here? D and T. So we're going to have D1T1 has got to equal D2T2. Okay, so I know D is 20 when T is 2, and we want to find the value of T when D is negative 5. So simple enough. 20 times 2 is 40. Negative 5 times what is 40? Negative 8. Negative 8. So again, as one goes down, the other goes up. Do you remember what the graph of inverse variation looked like? We called it the hyperbola, where it looked kind of like two quadratics repelling against each other. Asymptotic to both axes. Okay. But what this means here is that whatever this value, we'll call that x1, and if I trace x1 up to the graph, then I would get y1. Well, whatever x1 times y1 is equal to, it's always going to be the same no matter where we go. Those two products will always give us the same value. Positive times positive is positive, negative times negative is also positive. So we could have a hyperbola that looked like this, or we could also have a hyperbola that looked like this. Okay. Where in this case, one value is positive and the other is negative. And they have both a negative on both of those. With inverse variation, will you see direct variation at all? No, absolutely not. You won't see direct variation. Direct variation is algebra 1. Okay? Those ones have a constant ratio. These ones have a constant product. These ones are easier. Okay? All right with 12? Good. Moving on. Trig, we just recently saw this one. The sine of angle A is equal to negative 7/25. And they're telling me that angle A terminates in quadrant 4. Does that make sense? Is sine negative in 4? Absolutely it is. They want to know what the tangent of angle A is equal to. Can we do this one straightforward on our calculator? Absolutely can, right? If they tell me any trig function of an angle, can I figure out what the angle is? How? Inverse trig. Yep, we're going to use second sine. So let's go into our calculator. Does it matter what mode we're in? No, this one doesn't matter what mode we're going to be in. So it's whatever you're comfortable in. You guys are comfortable still in degree. I'm more comfortable in radian. So you're going to be in degree. I'm going to be in radian. We're going to find out that we get the exact same answers, even though we're getting different angle measures. So you guys go to degree. I'll stay in radian. And what I want to take is second sine. But what am I going to take second sine of? Not negative. What are we finding when we use second trig functions in our calculator? A reference angle, which are always found where? Quadrant 1, where everything is positive. Okay, so I'm getting a radian measure of 0.28 radians, a little more than a quarter of a radian. You guys are getting 16 something. Okay? So we're going to store that. No, I'm sorry, we're not going to store it as angle A yet, because angle A is in quadrant 4. So how do I take this reference angle that I now have and put it into quadrant 4? You guys have to go 360 minus. I can't do 360. I have to do 2 pi. So you guys will do 360 minus. I will do 2 pi minus. Now we have our fourth quadrant angle, yes? Store it as A. And now ultimately we want to find what? The tangent of A. We want to find the tangent of angle A. Whoops. And I would like to have it as a fraction. Choice number? Choice number 2. Choice number 2. Now what I do like about the multiple choice ones on these is we really can't eliminate a lot of them. If we know the angles in quadrant 4, what do we know about tangent in quadrant 4? It's negative, but all my choice is negative as well. So I can't eliminate any of the choices. If we had a couple positives up there, we'd automatically be able to get rid of them because we know the tangent in quadrant 4 is positive. Okay. Any question on how we do that on a calculator? Now, what I just did there, is that Algebra 2 trig level mathematics? No. When were you first exposed to the inverse trig to find angles? In middle school and Algebra 1. We've done nothing above the Algebra 1 level right there with that. Mark that one down again. 13 is straightforward calculator. We need to know nothing at our level of mathematics to be able to get 13 correct. Now, let's talk about how we would do 13, though, if this was a Part 2 question, because it quite often is. This is another type of question they could put in Part 2. Okay? When they tell me a trig function and what it's equal to, we know that these trig functions represent a ratio. And that ratio represents two sides of a what? Of a right triangle. So let's draw ourselves a right triangle. But we know that we're in quadrant what? We know we're down in quadrant 4. Well, in quadrant 4, our hypotenuse will always come out from where? The hypotenuse will always stem out from the origin. I will then draw a vertical line up to the x-axis, and that vertical line represents my opposite. The diagonal is my hypotenuse, and the x-axis is always the adjacent. Well, the sine function is the ratio of which two sides? The opposite to the hypotenuse. So my hypotenuse is 25. My opposite is 7. Is everybody clear on why it's a negative 7? Why is it a negative 7? It's on the negative side of the y-axis, right? It's below the x-axis, so it's negative. Now my adjacent side is going to be what? Positive, because it's on the positive x-axis. How would we find that adjacent side? We would use the Pythagorean theorem. Luckily here, this is not a triple that you're going to remember, but it's another triple. It's a 7, 24, 25. Just like a 3, 4, 5, there's a 5, 12, 13, and there's an 8, 15, 17, there's a 7, 24, 25. Doesn't matter if we don't remember it or not, we've got the Pythagorean theorem. Okay? Well, we wanted ultimately the tangent. Well, the tangent is the ratio of which two sides? O to A. Which is why tangent can be greater than 1 or less than negative 1. Because the opposite could be greater than the adjacent, or it might be less than the adjacent. But sine and cosine must be between what? Negative 1 and positive 1, because my hypotenuse cannot be smaller than the opposite or the adjacent. Hypotenuse is always going to be the larger, which restricts that inside there. So we get O over A, negative 7/24 is how we would do that by hand. I like that question when it shows up in Part 2. Okay, we've got to show our work, so you've got to show your diagramming of the triangle out and understanding what your trig ratios are. I think that's a good question for Part 2. Is it still really our level? You could argue it. Okay. But in multiple choice, that's a straightforward calculator one. Okay, and again, we've got to be very comfortable with that right there. Okay, and I know a lot of us aren't. But if they give me a trig ratio, I've got to be able to use that ratio to determine what the angle is by using second trig function. Okay. Good with 13. Okay, moving on to 14. What do we call this? sigma, and what does it represent? Summations. We're going to be adding things together. Okay? And what I'm going to do is I'm going to first replace n with what? First going to replace n with 1. I always like to make a little table when I do summations. I like to show one column for my variable, which in this case is the n, and then my next column is the expression that we're going to be plugging n into, a minus n squared. So what are the numbers that we're going to be plugging in for n? 1 through 4. 1, 2, 3, and 4. Okay, so what will my expression look like when I replace n with 1? A minus 1 squared. A minus 2 squared. A minus 3 squared. A minus 4 squared. Okay. How do we square something? Okay, so a minus 1 times a minus 1, how do we multiply binomials? We FOIL it out. What's a minus 1 times a minus 1? A squared. Yeah, minus a, which together is going to be minus 2a plus 1. Negative 1 times negative 1 is a positive 1. So that's what we're going to get there. What are we going to get with a minus 2 squared? A squared minus 4a. 2a and 2a is minus 4a plus 4. A squared minus 6a plus 9. A squared minus 8a plus 16. Okay. Well, we haven't done this yet. What do we now have to do with those? Now we've got to add them together. Okay, so how many a squareds do we have? 4 a squareds. Does that eliminate any of my possibilities? Yep. Choice 1, choice 3 are out of the question. Why is choice 2 out of the question as well? We need our third term. We need our third term. Okay. And if we look together here, 6 and 4 is 10, 8 and 2 is 10, 10 and 10 is negative 20. 9 and 1 is 10, 16 and 4 is 20, 20 and 10 gives me the 30. Okay, now, n was the variable that we were replacing. There was another variable in here as well, though. What was that? A. Could we have made a be any number we wanted and figured out what the summation was going to be equal to? Absolutely we could have. We absolutely could have. Do you remember when I showed you in your calculator how to do the summations? And I don't even know why I'm going back over this, because the summation you should do by hand. It's easier to do by hand than it is in the calculator. But can we do it in the calculator? Yes. So what I'm going to do is I'm going to take whatever prime I want. I'm going to take pi. I'm going to store it as a. Okay. And where do I go? I can't remember where to find things. I go into my catalog. I'm going down to the catalog, and I'm looking for summation. Well, summation starts with S, but it's SU, which is closer to what? So I'm going to go down to the T's, which is number 4. I'm going to go to the T's. I'm going to arrow up, and lo and behold, right there's my summation. Okay, well, there's 4 things I need to enter with a summation. The first thing I need to enter is what we call the summand. The summand is the variable or the expression that you're going to be plugging things into. So I'm going to type in parentheses a minus. Now, can I use n? Could I also use x, though? Yeah, it doesn't make a difference. I'm going to use n. A minus n, close it and square it. Now, what is the variable that's getting changed, the a or the n? The n is the variable that's getting changed, so we want to take this with respect to n. What's the first number we're going to replace n with? 1, and what's the last number we're going to replace n with? 4. Okay, so, folks, by me storing some number for a, that means a is no longer a variable. It's a constant in there. And then n is going to get replaced with numbers. So when I find the sum with n being 1, 2, 3, and 4, and a being pi, oops, closed off everything, didn't I? A minus n squared with n, 1, and 4. Are you guys getting the same there? Summation of a minus n squared. Let's do this. Let's change the n to x. It's still giving you the error. Yes. And again, you know what? Shouldn't make a difference. And I'm in 8th, so yeah, it's not going to make a difference. Oh, okay, good. I don't know. Not only do we need sum, but what we're defining here is a sequence. It's a sequence of terms, so we need the sum. And right inside the sum here, where you have your second parentheses insert, which is second delete, we then need to go back into our catalog and go to the S's. We want the sum of the sequence of terms, SEQ. The sum of the sequence. That closes off the sequence. That's going to close off the sum. There we go. All right, everybody get the number when we put the sequence in there? Okay, and now, since I have a stored as a number, I can now type in my answers. 4a squared minus 20a plus 30. Lo and behold, same exact thing. So can these be done in the calculator? Yes. Would I recommend doing a summation in the calculator? No. No. Do it by hand. Do it by hand. Okay. You know, I think I've shown you guys twice. Jake, I don't even know if I showed your class. We might have run out of time with third period. Do you remember me showing you that at all? Okay. It's not necessary to. I mean, couldn't even remember how to do it. Okay, so sequences and summations, just do those out by hand. Okay. Question on that one at all, folks? Great circle question. I really don't like the questions that go back to geometry with the circle, but I really like these ones. This is not the center radius form of the circle. This is the standard form, because it's set equal to what? Set equal to 0. But can we turn this into center radius form? Absolutely we can. We're going to bring our x's together. We're going to have x squared minus 16x. And then I'm going to group my y's together. We're going to have y squared plus 6y. I'm going to move my constant over as a negative 53. Why did I leave room in those parentheses with the x's and the y's? What do we have to do? We've got to complete the square. We've got to complete the square. Okay? So how do we complete a square? Okay, so half of negative 16 is negative 8. And then what do we do with negative 8? To get? So we've got to add 64 here, which means we also have to add 64 over here. All right, what's half of 6? 3 squared is So we're going to add 9 here. We've got to add 9 over here as well. Okay, why did we do that procedure? Well, that gives me now a perfect square trinomial. What is the number that when I multiply it by itself, I get positive 64, but when I add it to itself, I get negative 16? X minus 8 squared. Plus, what's my perfect square value for y? Y plus 3 squared equals... All right, if I'm going to take away 53 from 64, I'd be left with what? 11 and 9 gives me 20. So what is the center of this circle? Positive 8, negative 3, and what is the radius going to be? Radical 20, because this represents the radius squared. X minus 8 squared plus y minus k squared equals r squared. So we have a center of what? 8, negative 3, choice 3, 8, negative 3. Okay. That's the Algebra 2 trig level circle question, as opposed to them just giving us this directly and asking what the center radius is. You had that in geometry, didn't you? There's nothing different with that. This is the Algebra 2 trig level. We've got the the standard form, and they want us to take it back into center radius. That's the good question. Okay. All right, 15. Moving along. See if we can get through these last 12. Okay, domain and range. What does domain represent? The x values. What does the range represent? Well, if I want to check this function to see what the domain and range would be, what should I do with it? I should graph it. So let's go to y equals. We got 3 divided by the quantity, radical x minus 4. Close off the radical, close off the bottom. 3 divided by the square root of x minus 4. We always start our graphs with what? Zoom 6. And so there's my graph. Do the x values keep going to the left, or does it get to a point where they kind of stop? It's to a point where they stop, right? Okay, and we can see that by what's happening here with the pixels, is they are becoming a straight line vertically, aren't they? Okay, so as we keep tracing on this here, notice there are no y values over here when x is 0. Keep moving over, and I don't get my first y value until x is greater than what? Until x is greater than 4. Okay? So, look at these. Do they all have x is greater than or equal to a 4? Okay, so that's going to eliminate 2 of my choices. Can x be 4? Why not, Carolyn? Explain. If x was 4, what would we get down here? 0. Can we divide by 0? Absolutely not. So are 1 and 3 gone, or are 2 and 4 gone? 2 and 4 are gone. X cannot be equal to 4, but it can be greater than 4. Check out our y values. Okay, so as I keep tracing, it looks like y is up here at 14, and then we keep getting it down slower and slower and slower. I mean, as we look at our options, though, here, is y ever going to get lower than 0? No. Is it ever going to equal 0? No, it's never going to equal 0 as well. The only way that that expression could be equal to 0 is if my numerator was 0. Was my numerator ever going to be 0? Numerator is never going to be 0, so it can't be an equal to 0. So that allows me to cross off which other one? Choice number 3. Choice number 3 is out. Okay. So x is going to be greater than 4, y is going to be greater than 0 on that one there. Whenever you got domain range questions, the easiest way to take care of those is looking at them graphically. Okay. Now, if this right here were a part 2 question, how do we solve for the domain of a function? Well, this has 2 red flags. First off, we've got a denominator. What can we not divide by? Okay, and now we've got a radical. What type of numbers do we not want under radicals? So we've got to take that expression that's under the radical and make sure that it's greater than 0. If it was less than 0, we'd have an imaginary number. Can it be equal to 0, though? No, because it's in the denominator. So we solve this out. X has got to be greater than 4. That's our domain. X is greater than 4. Okay. 2 red flags for domain. Fractions and radicals. And this one has both. It has a radical in the bottom of a fraction. The bottom can't be 0, and radicals have got to be greater than 0. Okay. So we can solve that one out through. 17, a permutation combination question. 30 boys, 20 girls. Which represents the total number of 5 different member teams? Teams. So we're just forming teams. Is there a hierarchy or an order to a team? No. We just want members on the team. So permutation or combination? These are combinations. Bang, bang. They're out. Okay? And then counting principle. We've got boys and girls. So we've got so many boys and so many girls. Are we going to add the groupings together or multiply the groupings together? Counting principle says we've got to multiply them together. If there's this many ways to do this and this many ways to do this, then we've got to multiply them together, not add them together to get that one. So that one has 30 boys. We're going to choose 3 of them. 20 girls. We're going to choose 2 of them. We're going to multiply the number of ways that can happen together to get that basic combination question. Okay. Very rare on this exam, though, to have 2 kind of permutation combination questions like this one did. With the mathematics one, the permutations with repetition, and then just this basic counting principle one as well. Very rare you'd have that many questions on that basic one. And then I believe in part 3, didn't this one have the one with the geraniums? What was the probability that at least 4 of the 5 were going to seed? So there was a lot of probability on this exam, more than normal. More than normal. Okay. Questions on either of those 2? Okay, back to a quadratic one. Product of the roots. Sum and product of the roots. What was that little saying we had for the sum and the product of the roots? Some bad apples. Bad meaning negative. Some bad apples produce canned applesauce. Which one do we want? We just want the product one over here. What is our A value? 1. What is our B value? -4. And our C value currently is K, right? Okay. So, they want to know what is the product of the roots if one of the roots is 7? Okay. Well, folks, all we know is A and B. We can't find the product right now, but we can find the what? We can find the sum. The sum of the roots is going to be negative B over A. Well, negative is, so positive 4. My roots add to give me 4. Well, I know one of them is 7. 7 plus what is going to give me 4? -3. My other root is -3. So if one root is 7 and the other one is -3, then what is the product of the roots? -21. If one of the roots is 7, the other one's -3, they multiply together to give us -21. That's the question I like to see about the sum and the product of the roots as well, because you've got to use really kind of both of the setups on this one. I'd rather it be in part 2 where you're showing your work to get it, but that's the good question with this one. How many distinct triangles? Law of sines or law of cosines? Law of sines. This is ambiguous case. What's the pair that we have? The D's. 5 over sine of 32 is going to be equal to 8 over sine E. What mode do we want to be in here? Yeah, we want to be in degree mode. Tell me, please, what times what divided by what? 8 sine 32, make sure you close it. Divided by 5, that gives me the sine of the angle. Can sine be equal to that? Yes, it can. How do we find the acute angle? Second sign, second answer. How do we find the obtuse angle that it could also be? 180 minus. All right, now I need to check to see individually if these two will work. What is the one angle we knew? 32. Okay, well, will 32 and 58 leave me room for a third angle? Absolutely they will. Will 32 and 122 leave me room for a third angle? Absolutely will. How many triangles can we get out of this one? Which one gets scrapped automatically? You can never get 3 triangles. That one gets scrapped automatically. We find there are 2 triangles that can work in this case. If only one of them worked, then it's 1. If neither of them worked, it's 0. Usually what happens when none of them work is that you're going to get sine is going to be equal to something that's greater than 1 or less than -1. You can't take the inverse sine of that. Your calculator won't let you even. Okay. All right, with that one? Moving on. Normal distribution. Where are we looking when we see normal distribution? We're going to our bell curve, right? We're going to our bell curve. So let me do this really quick, and then I'm going to go and I'm going to copy that bell curve over onto this page so we've got it right next to us. So now again, I don't care if you take the scrap paper out, but we will tear this one out so it is sitting right next to us, so we're not searching for it and thinking that I remember it and I really don't. Because I just don't want to go back to it. There we go. Okay, applied to a college that requires students to score in the top 6.7% on the mathematics portion of an aptitude test. Scores on the test are approximately normally distributed with a mean score of 576. Where does that 576 go for us? That's the 0. The 0 represents the mean. With a normal with a standard deviation of 104. Okay, so add for me, please. What's 576 plus 104? 680. Another 104. 784. Another 104, please. 888. Now, why am I not bothering with the lower ones? It said the top 6.7%, the top 6.7%. What is the minimum score Liz must earn to meet this requirement? So we're going to start up here and work our way back in. And what are we going to be adding? Percentages until we get as close to 6.7 as we can. So 0.1 and 0.5, that's so there's 0.6. So add for me 0.6 and 1.7. 4.4. There we go, 6.7. We've got to be up above here. We've got to be up above here. Okay, so 784. We can go a little bit below 784, but can we go down to the 680? No. So we want the score that is going to be in between the 680 and the 784. Are there multiple scores that meet that? Yes. It could be this one or this one. So what we want to do is we want to actually find that one. So what is half of a deviation? 52. So what's 680 plus 52? She needs to score at or above a 732 if she's going to get accepted. The question I really like on the normal distribution one, though, is they give you a population. There's 1 million students who took this SAT. And they want to know how many of them scored between here and here. So that means you've got to find out what percentage of the scores are going to fall in there, and then multiply that percentage by the actual population to get an answer on that. Okay, but that one's not bad as well. Normal distribution, we're always going to our table. All right, with 20? Good. Let's see if we can do this. We got 12 minutes to do 7 problems. Boom. 21's easy. Why? That's a calculator one. Any question on how you would do this in the calculator at all? Where do you go to get a cube root? Math. Math gives you a cube root. Now, you're going to store some number as x, and you'll go through this. But let's review this concept because it is important. We are looking at what kind of a root? A cube root. So we're looking for how many equal factors? 3. Well, 27 happens to be 3 times 9, and then 9 is 3 times 3. 27 is just simply what? 3 times 3 times 3. So the 27 comes out completely as 3. But can the x squared come out? No. So 3 cube root of x squared. 16. Well, 16 is 2 times 4. I'm sorry, 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So there's 3 2's. So a 2 will come out, but there's also a 2 that stays under. So 2 cube root of 2x squared. Okay. What's 2 times 3? 6 cube root of 2x to the what do you do the exponents when you multiply, folks? You add them, 2x to the 4th. So now do I have 3 factors of x? I do. So what else also comes out? An x. I'm still left with an x underneath. Which choice? Oh, that was x to the 4th. Shoot, that was x to the 4th. So it should be x to the 6th then, right? So x to the 6th means there's how many factors of x? 6 of them. Well, how many pairs of 3 will come out then? 2. 6x squared, cube root of 2. Choice? Choice 4. Choice 4. Again, did we do too much work for multiple choice, though? Yes, we store a value for x, we go along with it. Okay. Folks, which sketch shows the inverse of y equals a to the x? What kind of a function is this? And they're saying a is just a number that's going to be greater than 1. So is a variable? No, it's any number that you want it to be greater than 1. Well, what's the easiest number greater than 1? Y equals 2 to the x. What kind of function is that? What do exponential functions look like? Asymptotic to? That's what my exponential function looks like. So which one's out of the choice? Can't be it. Choice? Because they're asking me for the what of it? They're asking me for the inverse of it. Not what the function is, what is the inverse of it? Choice 1's out of the question. That is y equals a to the x right here. They want the inverse. What do inverses do? Switch your x's and y's. Switch your x's and y's. Okay? So this one right here has the coordinate 0, 1. Well, the inverse has got to have 1, 0. All right. Which one? Choice 3. Inverses are reflections in y equals x. They're reflections of each other in y equals x. This is the inverse of the exponential function. What is that function called? The log function. If that is the log function, remember log bacon and eggs and be happy? Conversion back and forth. We first introduced logarithmic functions as the inverse of an exponential function. We were very comfortable with exponential functions after that chapter on them. We knew what they looked like. We know that they were asymptotic to the x-axis. They always crossed the y-axis at whatever your a value was. Well, then we talked about the inverse of it, so we're comfortable with the inverses. We knew we just switched to x and y's and we replotted them out. So we graphed them out, and that became then our log function. So choice number 3 is the inverse of that exponential, and that's our log function. Okay. Questions on that one? 23. What are we doing on 23? We're going into the calculator again, right? We're going into the calculator. What do they want us to do here, though? This is all just factoring. Okay. What multiplies to 22 that's going to subtract to give me 9? 11 and 2. Plus 11 minus 2 or plus 2 minus 11? plus 11 minus 2. What type of factoring is this one right here? Dots. X plus and x minus 11. X plus and x minus 11. Folks, we don't divide. We do what? We multiply by the reciprocal. So what is the reciprocal of 2 minus x? 1 over 2 minus x. And then before we multiply, we're going to do what? We're going to cancel the like terms, right? Those knock out. X minus 2 and 2 minus x. Are they the same? What do they reduce to? A negative 1. So we're going to hold that negative 1 up on top. So what do we have on top? Negative 1 over x minus 11. That's not one of my choices. But there's an equivalent choice up there. 11 minus x. This here is the same as saying negative 1. Now if I factor a negative out of the bottom, this positive x would become a negative x. And that negative 11 would become positive 11. And then what would happen to the negatives? They would cancel out. And then I would have a positive 1 over 11 minus x. Choice number 4. Choice number 4. You're actually better off doing that when they're on the calculator than making that quick mistake right here. You know, you're going to start to panic here. Well, it's not my answer. And then we could easily make a mistake making that switch. That one's much better to just do in the calculator. All right, on 23? Now, when you do 23 in the calculator, do you really multiply by the reciprocal? No, you just divide by the parentheses 2 minus x. Can 24 be done in the calculator as well? It absolutely can be. Absolutely can be. Okay. You want to test a value on each side of every number that they have circled. And just test it into the inequality to see which one works. Okay, so let's do this one. We haven't done this one in a long time. Okay, so let's look at this first one here. What's the value to the direct left of 5? 4. So we're going to store 4 as x. And we're going to see if parentheses, x plus 16, close it, divide it by the quantity of x minus 2, close it. Now where do we get our equal and all of our inequalities from? Second math. We want to see if it's less than or equal to, which is option number 6, it's less than or equal to 7. Does 4 work? 4 does not work. Okay, so let's look. What choices do they have where 4 does work? Okay, so 4 doesn't work, so this is a possibility. This one's not a possibility because they show that 4 works. This one's a possibility because 4 doesn't work. This one's not a possibility because 4 does work. Okay, so it's between 1 and 3. Okay, well, what do 1 and 3 have in common? Greater than 5. So I'm not going to test to see if greater than 5 works. I'm going to test to see what they don't have in common. This one says that what will work. This one says 0 will work. This one says it won't. So I'm now going to test 0. Go ahead and do that for me. Store 0 as x and run it back through that same test. Tell me if 0 works. 0 does work. So which one shows that 0 does work? And then 4 that we had, choice number 3 is the only one on this one. Choice number 3 is the only one on this one. This is a definite calculator one. How do we undo division by x minus 2? We're going to multiply over here by an x minus 2, and then it's going to become just a regular first degree inequality, but much easier to do that on a calculator than by hand. Okay. All right, with 24, we're pushing it here. $26. What are you doing on 26? Any questions on that one? Okay. By hand, you're distributing and then combining like terms. sort of values out. 5 radians. How many degrees is 5 radians? How do we convert radian to degree? I have 5 radian. What am I going to multiply by to change it to degrees? (180 degrees over pi radian. What unit cancels out now for me? The radians. Is there a pi to cancel out, though? No. So just multiply it. 5 times 180 divided by pi. 5 times 180 divided by pi. What do you get? Okay, so our closest one then would be choice 1, 286 degrees. All right, so now 25. 25 is a trig graph where I really encourage you to go on to regentsprep.org and go through that trig graph section. Sine and cosine functions are what we call periodic functions, meaning that after a certain amount of time, they repeat themselves. Well, they want to know which one has a period of 4 pi. That means it's going to take 4 pi units, roughly a little more than 12 units, to complete one full cycle. Okay? Well, I can check this pretty easily graphically. Okay? What I'm going to do is I'm going to go into my calculator, and I'm going to go into my mode. And it's very standard, folks, that trig graphs are done in what mode? Radian. What is the standard for mathematics? Radian. Okay. So we're going to go into radian. I'm going to go to y equals, and I'm going to type in 3 sine 0.5 x. And then what I'm going to do is I'm going to go to my window. And I'm going to have my window start at 0, and I'm only going to take it out to 4 pi. I'm going to go from 0 to 4 pi. And you know how I'm going to scale them off? I'm going to scale them off by pi. So how many markers will I see along my x-axis? 4. Pi, 2 pi, 3 pi, and 4 pi. Sine, folks, I know sine has to be between where and where? -1 and 1, but it's being tripled. We're taking that sine and multiplying it by 3, so now it could be between -3 and +3. So -3 to +3. Okay. If this has a period of 4 pi, I will see one complete cycle on my graph. Do I see one complete cycle? Yes, because what's going to happen now right as it gets to here? It's going to start going back up through again. Okay, check out this one. Number 2, 3 sine 2x. If this has a period of 4 pi, I'm going to see one full cycle on my graph. Do I see one full cycle? No, I'm seeing a lot of cycles there, aren't I? Okay, 1/4 of x. 0.25x. Not going to see a full cycle, am I? Nope, same one. Okay, so we can check these out graphically. Period just means how long does it take to complete one cycle. Well, if they're telling me that the period is 4 pi, well, that's what I'm going to make my x-axis to be, is 0 to 4 pi. And I'm going to find out which one completes one cycle in that amount of time. Okay. All right with 25? Any questions on 26 or 27? I know we hit them quick, but basic calculator ones. This was a really good one this year. They had a lot of calculator ones in the part 1. A lot of calculator ones. Questions at all, folks? Okay, very good. Again, tomorrow and Thursday, I'm available throughout the day from like 10:30 to 1. You're more than welcome to come in and work on a practice Regents or ask me any questions that you want. Again, I won't be putting on a review, but you can come in and work on anything you want, ask any questions that you want. You guys don't have anything tomorrow, right? Global in the morning, Common Core in the afternoon, and then physics is also in the afternoon. So Again, 10:30 to 1, you're more than welcome to come in and work on a practice Regents or work on that trig graph stuff. Come in and go onto that regentsprep.org and look at the trig graph material. Questions at all, folks? Very good. Have a great evening, guys. Thanks for showing up.